Space and Science News. With James. In the vast expanse of our Milky Way galaxy, astronomers have stumbled upon a chilling glimpse into Earth's potential future. Imagine our planet, frozen and battered, orbiting a dim, dying star billions of years from now. Today, we'll be talking about an Earth-like planet discovered 4,000 light-years away, because why not peer into the crystal ball of cosmic destiny? This distant world orbits a white dwarf, the dense, cooling remnant of a star that once blazed as brightly as our Sun. What's truly astounding is how closely this planetary system mirrors scientists' predictions for our own solar system's future. As we contemplate this cosmic parallel, we're left with profound questions. Will Earth endure the Sun's inevitable metamorphosis into a red giant? Might humanity's destiny lie in the far-flung corners of our solar system, seeking refuge among the moons of gas giants? As we unravel this cosmic mystery, we'll explore the groundbreaking technology that made this discovery possible and the implications it holds for our understanding of planetary evolution. But first, let's consider this: if this is Earth's future, how much time do we really have left? Let's dive deep into this subject and uncover the secrets of our planet's cosmic destiny. In the vast expanse of our Milky Way galaxy, astronomers have made a groundbreaking discovery that offers a glimpse into Earth's potential future. A team of researchers from the University of California, Berkeley, has identified an Earth-like planet orbiting a white dwarf star, located approximately 4,000 light-years away. This remarkable find provides us with a preview of what might await our own planet billions of years from now, when our Sun has exhausted its fuel and transformed into a white dwarf. As we delve into this fascinating discovery, we'll explore the implications for our understanding of planetary evolution and the fate of our own solar system. We'll examine how this distant planetary system mirrors what scientists predict for the future of Earth and the Sun, offering valuable insights into the long-term survival of planets around aging stars. This discovery not only sheds light on the potential fate of our planet but also opens up new avenues for research into the life cycles of stars and their planetary companions. The story of this remarkable find begins with a cosmic phenomenon known as microlensing. In 2020, astronomers observed an event where the gravity of a distant star system acted like a lens, magnifying the light of an even more distant star by a factor of 1,000. This event, dubbed KMT 2020 BLG 0414, was detected by the Korea Micro-Lensing Telescope Network in the Southern Hemisphere. Initial analysis of the micro-lensing event revealed a system containing a star about half the mass of our Sun, an Earth-sized planet, and a much larger object about 17 times the mass of Jupiter, likely a brown dwarf. Brown dwarfs are failed stars, with a mass just shy of that required to ignite fusion in the core. The analysis also concluded that the Earth-like planet was between 1 and 2 astronomical units from the star, that is, about twice the distance between the Earth and Sun. However, the true nature of the host star remained a mystery, as its light was lost in the glare of the magnified background star and a few nearby stars. To unravel this mystery, Kemming Zhang and his colleagues at UC Berkeley turned to the powerful Keck 210-meter telescope in Hawaii. Using its advanced adaptive optics system, they observed the lensing system in 2023, 3 years after the initial event. By this time, the background star that had once been magnified 1,000 times had become faint enough that the lensing star should have been visible if it was a typical main-sequence star like the Sun. Surprisingly, Zhang detected nothing in 2 separate Keck images. This absence of light led them to a startling conclusion: the host star must be a white dwarf. As Zhang explained, our conclusions are based on ruling out the alternative scenarios, since a normal star would have been easily seen. Because the lens is both dark and low mass, we concluded that it can only be a white dwarf. The discovery of this Earth-like planet orbiting a white dwarf provides a unique opportunity to study a planetary system that has survived the tumultuous process of stellar evolution. The white dwarf, about half the mass of our Sun but smaller in size than Earth, is orbited by an Earth-sized planet at a distance roughly twice that of Earth's current orbit around the Sun. This configuration closely mirrors what scientists predict for the future of our own solar system. The identification of this system offers valuable insights into the long-term effects of stellar evolution on planetary orbits and the potential for planets to survive their host stars' transition to white dwarfs. It demonstrates that planets can endure the dramatic changes their stars undergo, from main sequence to red giant, and finally to white dwarf. The Earth-like planet in this system is now far outside the habitable zone of its dim white dwarf star, making it unlikely to harbor life as we know it. However, it raises intriguing questions about the potential for life during earlier stages of the star's evolution. Could this planet have once been habitable when its host was still a sun-like star? And if so, what implications does this have for the potential prevalence of life in the universe? The discovery is part of a project by Zhang to more closely study micro-lensing events that show the presence of a planet, in order to understand what types of stars exoplanets live around. There is some luck involved, Zhang noted, because you'd expect fewer than 1 in 10 micro-lensing stars with planets to be white dwarfs. This rarity makes the discovery even more significant, offering a rare glimpse into the fate of planetary systems around evolved stars. The discovery of this distant planetary system provides a fascinating glimpse into one possible future for our own planet. As our sun ages, it will eventually expand into a red giant, potentially engulfing the inner planets of our solar system. Earth's fate during this phase remains uncertain, but some studies suggest that our planet might survive by migrating to a more distant orbit. If Earth does survive the red giant phase, it could end up in an orbit similar to the one observed in this newly discovered system, about twice its current distance from the star. However, this survival comes at a cost. The Earth we know today would be dramatically altered, with its oceans vaporized and its surface frozen in the dim light of the white dwarf sun. It's important to note that Earth will likely become uninhabitable long before this final stage. As Zhang points out, planet Earth will only be habitable for around another billion years, at which point Earth's oceans would be vaporized by runaway greenhouse effect, long before the risk of getting swallowed by the red giant. This sobering prediction underscores the importance of understanding planetary evolution and the potential for life to adapt to changing cosmic conditions. The Sun's evolution to a white dwarf is expected to occur in about 8 billion years. During this process, the Sun will first expand into a red giant, increasing in size to potentially engulf Mercury and Venus. As it loses mass, the remaining planets will be forced into more distant orbits. Eventually, the Sun's outer layers will be blown away, leaving behind a dense, glowing ball, a white dwarf, that is about half the mass of the Sun but smaller in size than Earth. This discovery has significant implications for our understanding of planetary evolution and the potential for life in the universe. It demonstrates that planets can survive the tumultuous process of stellar evolution, even as their host stars undergo dramatic changes. The system also provides valuable data on the long-term effects of stellar evolution on planetary orbits. As stars lose mass during their red giant phase, their planets are forced to migrate outward. This newly discovered system confirms theoretical models of this process, showing an Earth-like planet in an orbit twice the size of Earth's current orbit around the Sun. Furthermore, this discovery opens up new possibilities for the search for life beyond our solar system. While the Earth-like planet in this system is now far too cold to support life as we know it, it raises questions about the potential habitability of planets during earlier stages of white dwarf evolution. Could there be a window of time when such planets might support life? These questions will undoubtedly drive future research in the field of exoplanet science. Scientists will be keen to study more systems like this one to better understand the prevalence of planets around white dwarfs and the conditions that allow for their survival. This research could also inform our understanding of the long-term habitability of planets and the potential for life to adapt to changing stellar conditions. The discovery also highlights the power of micro-lensing as a tool for studying distant planetary systems. As Joshua Bloom, one of the researchers involved in the study, explains, micro-lensing has turned into a very interesting way of studying other star systems that can't be observed and detected by the conventional means, i.e. the transit method or the radial velocity method. There is a whole set of worlds that are now opening up to us through the micro-lensing channel, and what's exciting is that we're on the precipice of finding exotic configurations like this. The discovery of this Earth-like planet orbiting a white dwarf is just the beginning. It paves the way for future research and missions aimed at understanding the fate of planets around aging stars. NASA's upcoming Nancy Grace Roman telescope, set to launch in 2027, will play a crucial role in this endeavor. The Roman telescope is designed to measure light curves from micro-lensing events, potentially discovering thousands of new exoplanets. Many of these discoveries will require follow-up observations using other advanced telescopes, such as the Keck Observatory, to identify the types of stars hosting these planets. As Joshua Bloom explains, what is required is careful follow-up with the world's best facilities, i.e. adaptive optics and the Keck Observatory, not just a day or a month later, but many, many years into the future, after the lens has moved away from the background star so you can start disambiguating what you're seeing. This long-term approach to observation will be crucial in unraveling the mysteries of these distant planetary systems. It will allow scientists to build a more comprehensive picture of how planetary systems evolve over time and how common systems like the one discovered might be in our galaxy. The discovery also highlights the importance of advanced technologies in astronomical research. The use of adaptive optics on the Keck 2 telescope was crucial in identifying the white dwarf nature of the host star. As telescopes become more powerful and observational techniques more refined, we can expect to uncover even more surprising and informative planetary systems. Future research will likely focus on identifying more planets around white dwarfs and studying their properties in detail. This could include searching for signs of atmospheres or other indicators of potential habitability, even in these extreme environments. Earth's far future, it also sparks hope and imagination. Zhang suggests that even if Earth is engulfed during the Sun's red giant phase, humanity might find refuge in the outer solar system. Several moons of Jupiter and Saturn, such as Europa, Callisto, Ganymede, and Enceladus, are believed to have frozen water oceans. As the Sun expands into a red giant, these icy worlds could thaw, potentially becoming habitable ocean planets. As the Sun becomes a red giant, the habitable zone will move to around Jupiter and Saturn's orbit, and many of these moons will become ocean planets, Zhang notes. I think, in that case, humanity could migrate out there. This tantalizing possibility reminds us that while the cosmos presents great challenges, it also offers hope for the continued survival and adaptation of life as we know it. The concept of migrating to these outer solar system moons raises fascinating questions about the future of human civilization. How might we adapt to life on ocean worlds? What technologies would be necessary for such a migration? These questions not only inspire scientific and technological innovation but also challenge us to think about the long-term sustainability and adaptability of our species. Moreover, the discovery of this distant Earth-like planet orbiting a white dwarf provides a cosmic perspective on the resilience of planets. If this planet could survive its star's tumultuous evolution, it suggests that life-bearing worlds might be more robust than previously thought. This resilience offers hope that even in the face of dramatic cosmic changes, the potential for life, and perhaps even advanced civilizations, can persist. The idea of humanity spreading to multiple worlds in our solar system also aligns with the concept of becoming a multiplanetary species, an idea often discussed in the context of near-term space exploration. The long-term survival strategy suggested by this discovery takes that concept even further, envisioning humanity not just on other planets, but adapting to entirely different types of worlds as our own star evolves. This discovery and its implications serve as a powerful reminder of the importance of continued space exploration and astronomical research. By understanding the fate of other planetary systems, we gain invaluable insights into our own future and the steps we might need to take to ensure the long-term survival of our species. It challenges us to think on cosmic timescales and to consider the legacy we want to leave for future generations of humanity. As we conclude our exploration of this groundbreaking discovery, it's clear that the universe continues to astound us with its complexity and potential. The identification of an Earth-like planet orbiting a white dwarf not only offers a glimpse into the possible fate of our own planet but also raises profound questions about the future of life in the cosmos. This discovery challenges us to think on a truly cosmic scale. It reminds us that the story of our planet and our species is intricately linked to the life cycle of stars. While the prospect of Earth's distant future may seem bleak, it also highlights the resilience of planets and the potential for life to adapt to extreme conditions. Moreover, this finding opens up new avenues for exoplanet research. The use of micro-lensing as a detection method, combined with advanced technologies like adaptive optics, is pushing the boundaries of what we can observe and understand about distant planetary systems. As we look forward to future missions like NASA's Nancy Grace Roman Telescope, we can anticipate even more exciting discoveries that will further our understanding of planetary evolution and the prevalence of Earth-like worlds in our galaxy. Perhaps most intriguingly, this discovery invites us to contemplate the long-term future of humanity. While Earth may become uninhabitable in a billion years due to the Sun's evolution, the potential habitability of outer solar system moons as the Sun expands offers a glimmer of hope for the far future. It's a reminder that as a species, we may need to think beyond our home planet to ensure our long-term survival. In the end, this discovery serves as a powerful reminder of the importance of astronomical research. It not only satisfies our curiosity about the cosmos but also provides crucial insights into our own place in the universe and the challenges we may face in the future. Thank you for joining us on this journey through space and time. If you found this exploration as fascinating as we did, please consider subscribing to our channel for more in-depth looks at the latest astronomical discoveries. Your support helps us continue to bring these cosmic wonders to light. Until next time, keep looking up and wondering about the vast possibilities that await us in the stars. Thanks for watching. Remember to like, subscribe, comment, share and click that notification bell so you never miss out. See you next week.